So good morning, everyone. My name is SamuelPachito, and allow me to introduce my research project titled Investigating Vulnerable Populations Inhabiting Sea Level Rise Resilient Geography in Miami, Florida. And so very quickly, we'll just go over the roadmap for this presentation. I will introduce some of the background information that I find important to fully describe the research topic and some of the major themes that sort of intersect in South Florida. We'll go over the research questions a few times to help you guys guide yourself through my presentation. I will describe the data, visualize the data, and describe my methodology, in particular, a bathtub method. Then I will go into my results and provide some analysis with some final thoughts, and hopefully we have some time for questions at the end. So these are the basic three questions here. Where is the high ground in South Florida? Who owns it, and why does it matter? And so this is a digital elevation model, and you can see the higher elevations are colored whiter and gray colors, and the lower elevations are in black. Superimposed within the study area are my four research neighborhoods, Little Haiti, Overtown, Little Fana, and Coconut Grove. So according to the Intergovernmental Panel on Climate Change, basically last century, we saw about 1.4 millimeters of sea level rise per year, but that rate's been increasing. And because the Earth is not a perfect sphere and the ocean's sea levels aren't even everywhere for different geophysical reasons and oceanic and weather pattern reasons, regional sea level rise is unique. So according to NOAA, the Southeast United States is seeing, for example, 0.5 meter sea level rise by 2100. Now, the NOAA numbers were adapted by a climate activist and planning group in South Florida, and they specifically tailored their numbers just for Southeast Florida. And so their numbers are a little different from the center panel, but in the short term, by 2040, we're seeing at least 1/4 meter by sea level rise. And by the medium term, we're seeing, by 2070, we're seeing at least 0.5 meter sea level rise. And by 2120, the long term, we're seeing between 1 and above 3 meters of sea level rise. So unfortunately, South Florida and Miami has a history of racism and redlining, even racial violence. And certain groups, minorities, and Black populations were pushed into oftentimes the least desirable areas. And these areas were either inland or many times higher elevations. They were away from the coastal amenities. Which brings us to the topic of this presentation, and that's climate gentrification. And basically, the higher elevations are now sought after by wealthier interests. And it's a well-known fact that people living directly on a coast will be most at risk to sea level rise. But as an externality of climate change, we should look at the higher elevation areas to see who might be affected in this process called climate gentrification. So we can find the high ground using digital elevation models. We can describe who owns it based on historic neighborhoods and by accessing census data. And we can say that this matters because we have to think about climate gentrification processes that might push out the already disenfranchised. And so this is my data. I collected 4 digital elevation model tiles from USGS, and those are in 1/9 arc-second resolution, which is roughly about 3 meters spatial resolution. And for demographic features, I collected data from the American Community Survey that spans 5-year estimates, 2015 to 2019. And lastly, I queried the City of Miami's repository to take a neighborhood shape file and to sort of snap it to the US Census lines. And these maps are just visualizing the data I just described. So on the left, we have the digital elevation model. In the center, we have the census tracts used in this particular study. And on the right side of the screen, we have the 4 neighborhoods in my study. This is my methodology, and it might look a little complex, but it's very straightforward. So the first row is I'm collecting the raster data, mosaicing it, and creating an elevation raster. Now, if we just focus on the left side of this methodology, you can follow along. The left side is basically the bathtub analysis. And so a bathtub analysis is setting a certain elevation value, so let's say 3 meters, and everything below that 3 meter is considered inundated or flooded. So I'm simulating sea level rise with a bathtub analysis. In my study, I'm using 6 different intervals for every half meter. So from half meter upwards to 3 meters. So I made 6 new rasters. I converted those float rasters into integers and those integer rasters into polygons and clipped those to my historic areas. And so essentially I had 6 layers showing areas that were flooded with their area calculated in square kilometers. Now, if we move over to the right side of the methodology, you can see that I converted my raster into points, and then I spatially joined those points to both my census tracts and to my neighborhoods. That way I had mean elevations at the neighborhood scale and down to the census tract scale. I also had all the demographic feature population counts per census tract and per neighborhood. And lastly, I summarized within. So I brought these 2 pieces of data together, and now I had historic areas, census tracts with mean elevations, as well as areas lost to sea level rise per half meter. This map is showing the demographic landscape. So this is sort of answering the question, who owns it today? And so if we look in the left panel, we see that Coconut Grove is mostly white, Little Haiti and Overtown is majority Black, and Little Havana is mostly Hispanic and Latino. This map is showing one of the vulnerable characteristics that I studied, and that's population below the poverty line. And so across the 4 neighborhoods, I found that nearly a quarter of the people were in poverty. As far as elevation for census tract, there are lower census tracts near the Miami River and some higher elevations in Coconut Grove, as well as Little Haiti. Coconut Grove, on average, is the highest above sea level neighborhood. And we can sort of combine those 2 pieces of information, the population below poverty and elevation. And so what you're looking at here is a bivariate map. And if you focus on the bright red census tract in Overtown, that area is describing a place where there's higher rates of poverty and higher elevation, which might imply that this area might be more at risk to climate gentrification, whereas places like Coconut Grove have lower rates of poverty and higher elevations. So those places might not be as much at risk to climate gentrification processes. And lastly, this is my bathtub analysis. You can see in the map on the right that there are 6 layers showing sea level rise, sea level inundation, and areas within each study neighborhood that are hashed out are above 3 meters. And then areas that are color-coded or correspond to the legend. Now, if you focus on the bar chart, we can quickly gather that Little Havana loses the most area, almost at every interval. But in the short term, at half meter, most of the neighborhoods fare okay, but during the medium-term projections, so this is around year 2070, between 1 meter and 2 meters, substantially more areas lost. And then lastly, in the long-term projections, 2.5 meters and 3 meters, some of these neighborhoods are almost gone. And it's also important to remember that these areas are already higher in elevation. And just to sort of recap some of the points I made here, most of the neighborhoods still retain the namesake. So some of the historical populations are still there, except for Overtown, which was a racially segregated neighborhood that sort of sequestered Black people. It's no longer mostly Black, it's mostly Hispanic and Latino. I also found that a quarter of the population is in poverty, and this is a factor of vulnerability, which might suggest climate gentrification could happen in that area. And Little Havana lost the most area. They lost between 1% to 54% across all the sea level rise intervals. And when we're comparing Little Haiti, Little Havana, and Overtown to Coconut Grove, we find that Coconut Grove has the least amount of poverty, higher elevations, and the greatest proportion of white people, which might suggest that Coconut Grove is the least likely to fall victim to climate gentrification processes. And so some of my final thoughts here. My bathtub analysis is a single variable bathtub analysis, meaning I'm using just one point of data, and that's elevation. Now, other bathtub analyses, other deterministic bathtub analyses can find a better cost surface when you can include things like hydrology and land subsistence, just other factors that might be able to create a more realistic a view of sea level inundation. But at the very least, at the scales that I'm using, a single variable bathtub analysis could definitely find and has found areas that are more at risk when we're comparing it to demographic features at the census tract level. And lastly, the reason why I wanted to research this topic is because I felt that maps are very powerful tools in describing identity. And I felt that it wasn't spoken enough about. And I hope that my viewers can understand that if we, as GIS practitioners, don't give voice to certain at-risk populations, they might lose their place on maps, their homes, and might lose legibility. And it's sort of part of our goal to help keep them permanent fixtures in any landscape. And so that wraps up my presentation. I do have some references, but I think there is ample time for questions.